Hi, welcome to the first of the AnimatLab tutorials. The purpose of this tutorial is to give you a broad overview of the features of AnimatLab. I'll try and demonstrate all of the important features while at the same time showing you how to create a simple virtual organism that I call a belly flapper. Let's take a look at the organism we'll be building during this tutorial. Once you've started the Animat application, you can open a pre-built version of this tutorial by clicking the Open Project button on the toolbar. This will display the Open Project dialog. If you installed AnimatLab to the default location, then you can find the project file by going to C, Program Files, AnimatLab, Tutorials, Belly Flapper. You can run the simulation by either hitting the F5 key on your keyboard or by clicking the play button of the simulation control toolbar. This will open the simulation window and run this model. As you can see, the belly flapper really does not do a whole lot. It's basically just able to move forward under its own power. It has 4 limbs with 2 motorized hinge joints per limb that it uses to push itself off the ground, move forward, and then flop back down onto the ground. Then it does it all over again. This sounds kind of boring, but I believe that once you are done, you will be surprised at how much thought you have to put into creating something that produces a behavior even as simple as this one. In the process of building this simple creature, we will learn about laying out the body of an organism, building the neural network to control its behavior, and displaying data so we can understand what's happening. So let's dive in and start building our organism. Let's begin by closing the current project using the File menu. Then we'll create a new project by selecting that menu item. This displays the New Project dialog. For those of you familiar with creating files in applications like Word, AnimatLab operates a little differently. A project is a collection of files, so AnimatLab will create a new directory for you and maintain all of those files. To create a new project, you must specify where you want that directory created and the name of this project. So let's create this model in the Projects folder of the AnimatLab directory and call it Belly Flapper. Hit OK, and your new project will be created. Now let's take a look at the project workspace. You can find that on the left-hand side of the screen. Click on it and the window will pop out for you. If you don't like the pop-out feature for toolbars, you can pin any of them in place using the pin button at the top. The project workspace is one of the most important toolbars in the application. It shows you what major elements are in your simulation and lets you change the values for those objects. At the root, we have the simulation. Under that is the environment, which contains a list of organisms and structures. When you select any of these items, then the properties for that object are displayed in the grid below. As you can see, the properties for the environment typically control parameters for the whole simulation. This includes things like the magnitude of gravity, the time step for the physics engine, whether you will be simulating hydrodynamics, and if so, what fluid density should be used. Let's create our organism. You do this by right-clicking on the organism item to display the pop-up menu. Select New Organism and one will be added for you. An organism is composed of 2 parts, a behavioral system and a body plan. A structure, on the other hand, only has a body plan. Now that we have created an organism, let's change the name. Go down to the name property below and change this value to Belly Flapper. You can open the editor for part of the organism by double-clicking on the appropriate node. So let's go back up and double-click on the body plan node to open its editor window. The body editor window also has several toolbars which you will have to learn how to use. To the right is the hierarchy window. This control displays all the parts of the body using a tree structure. Below that is another property window. When you select any part of the body, the properties for that part are displayed here so that you can modify them. At the top is the command toolbar. There are several different modes you can use when building a body. You can switch between these modes using the buttons at the top. The first button puts the editor in the select body mode. When you're in this mode, you can click on parts in the view window to select them. Next to that is the button for the joint select mode. When you're in this mode, the body parts are partially transparent so that you can see through them to the joints below in order to be able to select them. After that is the button for adding a body. The final mode is for Receptive Fields. This is a more advanced subject and we'll be discussing it at another time. The next control is for mouse sensitivity. You can use this to increase or decrease how a change in your mouse position is related to a change in the world. This controls things like how fast you zoom or rotate. Finally, we have the default body part and joint type drop-downs. When you're in Add Body mode, it's these drop-downs that determine what type of body you'll be adding and what type of joint will be used to connect the new body part to its parent. Now let's add our first body part. Let's start by making sure that we're adding the correct part type. We want to add a box, so go to the default body part drop-down and select Box. Next, select the Add Body mode. Normally, you can only add a new body part to an already existing part. However, the root object is an exception to this rule. You can create a root node by clicking anywhere in the View window. Newly created parts are selected by default. You can deselect it by clicking anywhere in the black space of the View window. You can select it again by clicking on that part. When a part is selected, it is enclosed by a semi-transparent bounding box. It also has a selection box in the middle that can be used to move or rotate that part. The selected part also displays an orientation axis that shows its orientation relative to its parent. Let's get a better look at that axis by rotating our view. You have the ability to rotate, pan, and zoom in the View window using your mouse. To rotate, you simply need to left-click on any empty space and drag the mouse. Zooming can be performed in two different ways. The first is to hold down the Control key while you left-click on empty space and drag. However, a simpler method for zooming is to simply use the thumb wheel on your mouse. Panning can be used to move the location of the camera. You can do this by holding down the Shift key while you left-click on empty space and drag the mouse. You can also change the size of an object using your mouse as well. To do this, you need to left-click on the bounding box of the side that you want to size and then drag. This is similar to stretching the part in the dimension that you're dragging on. However, it's often more accurate to set the size of a part directly by using the property grid. Now we've sized our part by dragging on it, but it's not the exact dimensions that we want for our root body part. So let's undo the changes that we just made. Anytime you make a change to an item in the application, you can undo that change by hitting the Ctrl-Z key. A list of the changes we've made since the program started is kept in memory. This allows you to undo an entire string of events. We can hit the Ctrl-Z key several times and watch each of our changes roll back. If we accidentally undo too far, you can use the Ctrl-Y key to redo that event. In this case, we undid the creation of our root body. If we hit the Ctrl-Y, then our body part is added back. The undo-redo buffer works for all the parts of the application. However, when you close a window, then all the changes that were associated with that window are erased from the undo history and cannot be recovered. Now, let's go and manually set the size that we want for our root body part. Go to the Property Grid and find the Size section. If you double-click in the Edit portion of the Height property, it will highlight the value. Type in 3 and then hit Enter. When you change a value without specifying the units, then the application will assume that you want to use the same units that it previously had. This eliminates the need to tediously type in the units every time you want to change a value. Next, let's go to the Length property and change it to 30 centimeters. We'll keep the width at the default of 10 centimeters. Now go to the Name property of this object and change it to Body. Go back to the View window and rotate our body part so that its Z-axis is pointing into the screen. Then switch to Add Body mode. We want to add another box that is connected to our root body by a hinge joint, so our default part types are already correct. Let's go back down to the root body and click on it where you want the new part created. Once you do, a new part appears in the root body where you clicked it. Go ahead and change the name of this new part to be Left Upper Elbow. Since we will have 4 legs, we will use a naming convention of left, right, and upper lower to distinguish between the parts in the different legs. When a part is created, the application attempts to place it on the surface of its parent object, so sometimes it adds a rotation to the new part to make its orientation correct. However, in this case we don't want any rotation, so change the Y rotation value from -90 degrees back to 0. Then let's set the size of the elbow. Use a height of 2.8 centimeters and a length and width of 2 centimeters. Finally, let's change the color of this part so that it's easier to distinguish it from the root part. Go up to the color property and click on the little drop down symbol that is on the side. This will display the color selection drop down. Select blue. Now let's talk a little bit about how you can move and rotate parts in the body editor. You can do this using either the mouse or the property grid. We will start with the mouse. Zoom in a bit so we can see the elbow more clearly and then select it. You should see the selection box in the middle of the elbow. You can move a selected object by left-clicking on this selection box and dragging it. This will translate the object in the XY plane. If you hold down the S key while you do this, then it will translate it in the YZ plane instead. If you begin moving an object and it doesn't move in the correct direction, then you can cancel that move by hitting the Escape key while you're still dragging the object. This will reset its position and orientation back to the point where you started moving it. For finer control, you can move the item along an individual axis. To translate along the X-axis, hold down the X key while dragging. You can do the same thing with the Y and Z keys to translate along those axes. You can rotate an object with the mouse using a similar procedure. The main difference is that you click on the selection box with the right mouse button instead of the left button. When you drag the mouse using the right button, it causes the object to rotate freely around its center. You can also rotate around an individual axis by using the X, Y, and Z keys like we did with translation. You can also set the location and rotation of an object using the property grid. Let's go back and find the section for location. When we do, we can see that there are actually two such sections. The first is for the local location, and the second is for the world location. So, what's the difference between these, and why do we need two different location values? The difference between these two settings is that the world location is the absolute location of this part relative to the origin, while the local location is relative to its parent's origin. We need both of them because sometimes in different situations it's easier to use one rather than the other. Let's look at an example. Select the root object and rotate it around the Z-axis by -45 degrees. Now select the elbow and look at the difference between the local and world coordinates. Set the X value of the local location to be -20 centimeters. The elbow moves out away from the body, maintaining the orientation between them. Undo that change and set the X value of the world location to be -20 centimeters. When you change the X value of the world location, it translates the part along the world X axis. But when you change the local X value, it moves along the parent's X axis that's shown when the part is selected. Undo this change and then set the Z rotation for the root body back to 0. Now let's set the location of the elbow to the values we will use in the simulation. Select it and set the local location to be -5, 0, and 10 centimeters. Now that we have our elbow positioned correctly, we need to do the same thing for the joint that connects the elbow to the body. Go to the Command toolbar and click the Joint Select mode. Notice that the body parts become semi-transparent and you can now see the hinge joint that's inside. The hinge joint has an axis of rotation that is shown by the central cylinder. It also has two flaps that designate the limits of rotation and an arc in the middle that shows you which direction that the hinge will rotate. Select the hinge and set its local X location to be 0.5 centimeters. Then scroll down and set its X rotation to be 90 degrees. Notice that the axis of rotation of the hinge joint has changed. Next, let's set the rotation constraints. These properties limit the maximum and minimum values that this hinge can rotate. Set the maximum to 45 and the minimum to negative 45 degrees. You can see that the two flaps have changed to the values we set. This means that this joint will no longer be able to rotate greater than 45 degrees or less than negative 45 degrees. Finally, let's change the name of this joint to be LU_body to elbow. We now have our first body part with a joint. So, we should probably test it to make sure that it's rotating in the way we want. First though, we need to freeze our root body. If we ran the simulation right now, there's no ground, so our organism would simply fall freely in space. When you freeze a body, you lock it so that the forces cannot act on it. The body will remain suspended in the air, but forces will still be able to act normally on the elbow. Go up and select the body part. Then find the freeze property and double-click on it to switch the value to true. You can use the drop-down to change the value as well. Now let's run our simulation. You can control the camera using the same set of mouse and key commands that you used in the body editor. If you left-click and drag, you will rotate the view. Dragging with the control key down will zoom, or you can use the thumb wheel on your mouse. Panning can be done by dragging while the shift key is down. However, the pan feature will only work if the camera is not tracking a structure. Close down the simulation, then go back to the project workspace and select Camera. One of the properties is named Track Structure. When this is true, then the camera will track the specified structure anytime it moves and will maintain the same view on it. When our simulation began, we were looking at the rear end of our organism. It would be better if we did not have to manually rotate it each time in order to see our elbow. We can do this by changing some of the camera's settings. Elevation sets how far above the track structure it should be. Offset tells it how far away it should be, and rotation rotates the camera around the origin of the structure. Change the elevation to 3 cm, the offset to 40 cm, and the rotation to negative 90 degrees, and then run the simulation again. Now let's test our joint. We can do this by grabbing onto the joint and moving it in real time. To do this, you need to hold down the Control and Shift keys at the same time and then click and drag on the part you want to move. You should see a white line drawn from the point where you clicked on it to the tip of your mouse. You now have a spring attached from the tip of your mouse to that point that's applying force. The further away you pull, the more force that's applied. Use this feature to move the joint back and forth and verify that it's moving in parallel to the body and that it's only rotating between 45 and negative 45 degrees. Now let's add the arm. Go up and select the Add Body mode. Then click on the elbow to add the arm. Change the color to green and change its name to Left Upper Arm. Next, set the rotation to 0 and the size to 2.7, 1.9, and 10 centimeters. Scroll back up to the local location and change the X value to negative 5.5 centimeters. And set the Y and Z values to 0 centimeters. Now switch to Select Joint mode and click on our new hinge joint. Change its name to LU_elbow to arm. and then change its constraints to be 20 and negative 20 degrees. Run the simulator again and test the new joints. When we do this, you should notice that there appears to be a problem with our first joint. We're able to move the arm up and down with the new joint okay, but it's much more difficult to move the arm back and forth. If we apply a small force to the end of the arm, it doesn't appear to rotate freely. It seems to hit some type of block. So, what could be causing this behavior? The answer is that the arm we just added is colliding with the root body. When you add a new part, collision detection between that part and its parent are automatically turned off. But in this case, our elbow is so small that when it rotates, the corner of the arm hits the body and prevents the full motion. We can solve this problem by disabling collision detection between the arm and the body. To do this, make sure that the organism node is selected, and then go to the Collision Exclusions property. Click on the button to display the Collision Exclusion Pair dialog. Select Body for Part 1, and select Left Upper Arm for Part 2. Hit the Add button, and then hit OK. Now let's run the simulation again and test our joints. You can see that both joints now move freely without the blockage that we saw before. Great! Now we've built our first arm. All we have to do now is build 3 more. Relax. It won't be quite as painstaking as building the first one. Now that we have one built, getting the other 3 will be pretty simple. All we have to do is copy and paste the one that we have. To do this, we need to select the upper elbow and then hit the Ctrl-C key. When you copy a body part, it copies the part and all of its children parts, which in this case includes the joints and the arm. Hitting Ctrl-P puts us into paste mode. Notice that in the control toolbar it looks like we switched to the add body mode, but when we click to add a body this time, it will add the copy of our arm instead of a new part. Set the location of the new elbow to be -5, 0, and 10 centimeters. Then change its rotation back to 0 degrees. Now, let's do the same thing for the arms on the other side. The only difference is that this time you need to specify a rotation of 180 degrees instead of 0. Now, we need to go back and rename all of the parts for our new arms using our naming convention of left-right and upper-lower. Be sure not to forget to add the collision exclusion pairs for our new arms so that we don't run into the same problem with them bumping into the root body part. Now let's test all of our new arms. Great! It looks like we have all the arms added and they're working correctly. So now let's add a ground surface. Go to the Project Workspace and left-click on the Structures node to display the pop-up menu. Then select Add Ground Surface. It's nice to have a texture on the ground for depth perspective. It makes seeing the organism move much easier. You can find a nice checkerboard texture in the Resource folder of AnimatLab. Go to C, Program Files, AnimatLab, Bin, Resources, and then copy the checkerboard bitmap and paste it into our project folder. Now open up the editor window for our ground surface. The ground plane is not visible at first, so you need to zoom out and rotate a little to see it. Change its color to white and then click on the texture property to display a file dialog. Choose the checkerboard texture and then hit OK. The texture will now be shown on the ground. We're finished with the ground, so you can close its body editor now. Before we run our simulation, we need to change the location of our organism. Right now it's located at 0, 0, 0. But the ground is also located at that position. This means that part of our organism would start up under the ground. Our organism is 3 centimeters high, so to fix this we need to raise it up by 1.5 centimeters. Finally, let's unfreeze the root body part so it can move freely, and then run our simulation again. Cool! We finished building the body for our simple organism. Now we need to focus on building the neural network that will control its behavior and actually cause it to move along the ground. We'll work on this and then finish building our organism in the second part of this tutorial.